Welcome back to Connect and Transform. By the end of this video, we should have a demonstration of machine-machine game mode with auto-playing features where it chooses a random valid move and pushes the piece around. I'm not sure if we'll get around to implementing turns where we alternate black and red, but we will at least get to the point where auto move is able to choose a random valid move and execute it. Before we get into the actual coding, I want to clean up the code a little bit. So for example, we have like a commented potential variable here that we haven't used before. And I'm noticing that if we look at the board and we look at the informational container here, we have variables for some of these four things, but not for all of them. So we have a variable for game mode. I'm going to take this game over variable and I'm going to change it to game winner, and we're going to default that to false, but that may be red or black depending on who wins. And then we're going to add a variable called possible moves, and that's going to track the number of possible moves at that moment. We're going to just default it to 0, but of course we're going to initialize it before we use it for any sort of logic. And then we are going to have a variable called current turn, and we'll default that to red moving first. The next thing that I want to do is I want to tab things to the left that are either temporary, like this bit that is highlighted right now. This is just temporary code to stage different scenarios. And I'm also going to tab over like these blocks of functions because we're not 100% sure that we're going to use every single function. As we end up calling functions, I will tab them over. And the block of functions that have not yet been implemented, I'm going to move them all the way to the left. That way, as I'm scrolling in the file, I know that anything that's all the way to the left definitely needs attention. Now, a lot of these other things like animations around moving, jumping, or promoting to a king, we know intuitively that each of these will eventually get used at some point in the game, as well as the function to apply a transition. We know that's going to be used. Generate board and generate pieces are directly called, so they can stay tabbed over, not all the way to the left. And so we see as we're scrolling that it's really just this one extended block of code that likely needs attention. And one thing that I'm seeing as we talk about creating these variables for this information box is that to my eyes, this text is a little bit tight and squished. So I'm going to go over into the CSS for the line regarding the default styles for text, and I'm going to add a style, letter spacing. We're going to give 1 pixel of spacing between the letters, so I'm going to go ahead and refresh. And that did open it up a little bit. It also necessitates now that we change the X position of all these text elements, and I realized that I could refactor this so that we might only be defining the X position once in a container, but it didn't take that long. It's already done. So now we've shifted all this text over to the left a little bit, so it's slightly more centered. It could probably use a little bit more work, but it's good enough for now. So the next thing we're going to do, we're going to reorder a few lines here. So generating the pieces in the board, we want to do that first before we read the URL to set the game mode. Because if the game mode is machine-machine, then we want to call auto move. And likely we're going to want to do a set timeout. But we will eventually go back to this and see if we can exclude the set timeout and just call it directly. And the delay that we're going to apply here will be the minimum delay. So we're calling auto move, but I'm not going to tab this function over yet because it's not yet implemented. But that is how the pieces would start moving in the case that it's machine-machine play. If it's human to human, there's not going to be anything automatic. It'll be based on a human clicking to select a piece and then clicking on a destination to authorize a move. And in the case of human machine, the first move will always be the human, unless I decide to change that in the future. Maybe we have a second URL parameter if we want the machine to run first. And in that case, there might be a condition to call auto move for human machine mode. For now, I'm going to comment out this temporary code that was staging things for a previous video. So that will no longer be getting in our way. And I'm noticing as I look at the code, there's an instance of index of that has a capital I. So I'm just going to copy the correct casing with the lowercase, and I'm going to paste it everywhere here that's incorrect. Okay, so I think we've now fixed all of the index ofs to be proper. So let's find some functions that we need to implement. I see a lot of things around moving. Maybe we'll begin with getting all moves for all pieces on one's own team, which will most likely involve creating a bucket to store the results, and then it'll be a loop that's going to call this function. So this function will likely take static ID as opposed to looking at the selected piece. So we're going to start by coding this get all moves for all pieces. And again, the subtext there is that it's all moves for all pieces on the team that is currently moving. So we're going to create something. We'll say let possible moves equals, and we'll just start that out empty. And then the next thing we're going to do is we're going to do a query. So we're going to query for pieces. But instead of doing query selector like we've been doing a lot of so far, we're going to do query selector all. And that'll be from the pieces container. And then within that, as child elements, we're going to be selecting use elements. And the use elements are going to have the class name piece. And specifically, we're looking to capture something that has the class name of either red or black, depending on who the current turn is. So we're going to be using that color value as the second class name in this query. So let me scroll up real quick and let's just see, because we have this variable current turn. It's all lowercase, and I think that is what we need, is all lowercase. So I think we can just use that global variable there. And now we have our pieces. Next, we're going to do for each within those pieces results. Okay, so for each piece, we're going to run this function to get all moves for that specific piece. So for the particular piece, we'll just create a constant. We'll call it allowed moves. And we'll say that that is equal to getting all the moves for that piece. And we're passing in piece.id. And then I'm going to just copy this as the basis for the next thing. So for all those allowed moves for one given piece, for each of those moves, we're going to push that move onto the result. So possible moves dot push move, and then I was going to say then we return the possible move, but that's not quite right, because in checkers, in most cases, if you can jump you are required to jump. So now we need to create another group, but instead of calling it possible moves, we're going to call it possible jump moves. And that's going to be equal to possible moves dot filter. And we're going to filter here. Let's see. So somehow we have to say that whatever move we return from this function, we have to say whether or not it is a jump. And my current inclination is that the move that gets returned from this function is going to contain an origin, a destination, and an action. And I think the action will be one of these 8 function names, 4 of which start with the term jump. So what that means is we can say where x.action.index of jump with a capital J equals 0. In other words, it starts with jump with a capital J, which would be true, for example, for jump piece northwest or jump piece northeast, if that happens to be the action component of your move. And maybe instead of x here, I'm just going to call that move to avoid confusion with x as a coordinate, because I know we use x and y a lot. Like even right there is an x. Okay, so then that tells us if there are any possible jump moves. So then we're going to say if possible jump moves dot length is greater than 0, then we're going to return possible jump moves. Otherwise, we're going to return possible moves. So if you can jump, then we're only going to return the set of moves that are jumps, so that no matter what you choose from that set, it will be a jump. Now, in the future, we do need to be mindful of the possibility that you might be continuing a jump that has already begun. You might end up in a situation where you could make multiple jumps from your current position, but only one of them is valid because you had already started jumping with a certain piece. So I think we're going to have to add some filtering to this in the future, but this is probably good for a first iteration. So let's look at auto move and what it's going to have to involve. So the first thing we're going to do is we're going to call this function to get all moves for all pieces. Okay, so at this point, we're calling this function from auto move, and we already know that we're calling auto move from the portion of the code that deals with the game mode and the URL. So as soon as we're done with implementing this, we'll tap this function over as well. And then this function calls get all moves per piece. So as soon as we're done with implementing this function, we can tap it over also. So first of all, we just got all possible moves for all possible pieces based on the current turn. After that, we're going to create a random index. And this is just temporary. In the future, we'll probably be implementing a heuristic and strategy, but for now, we're just going to pick a random valid move and choose that one to execute. So we want to make sure that we're picking something in the range of possible moves.length. Like that. Okay, so now we're going to update our selected piece. So we're going to say that that is possible moves at the index, random index dot source, because I mentioned earlier my predicted structure for a single move is that it's going to have a source, a destination, and an action. So we're storing the source as the selected piece. And then we're actually going to do the move now. So I'm going to rename this function to apply move. So we're going to apply a move, and we're going to pass that the actual move itself, just the whole move. So this function will take a move. And then if the game mode is machine machine, then we want to basically call auto move again after a period of time. And maybe that's after 1 second, let's say, and we're going to be calling auto move. And maybe we don't want to hard code that, so we're going to save that value and we're going to create a variable. And maybe we'll just call it auto move timing ms. Let's go add a variable for that, or a constant, I should say. Okay, 1,000, very good. And then because auto move is calling itself, we need some kind of exit condition. So we're just going to say if the game winner is defined, if it's not false, then we're going to return. And I think that does it for auto move. So we're going to tab that over. So now I need to decide whether we're going to work on apply move or get all moves for piece. I think we'll do this one next. It should be a lot faster. So this is basically just going to be a switch statement. And it's going to be on move dot action. Okay, I just wanted to get that break statement in there. So the actual function, for example, might be move piece northwest. So if I'm passing it in this string, then we're actually going to execute that function. And same with northeast, southwest, and southeast. Okay, so we've got 1 to 1, 1 to 1, 1 to 1, 1 to 1, and then we want the jump versions as well. Yes. So we have northwest, northeast, southwest, and southeast. Okay, let's just double check. 1 to 1, 1 to 1, 1 to 1, 1 to 1. And I think that'll be it for apply move. So we're going to tab this one over as well. I think all we need to finish for a demo is we just need to do this. Maybe I'll see if we'll see what kind of demo we can do right now. So we're going to be returning an array of objects, and each object is going to have a source, a destination, and an action. So let's just say that we're moving this piece right here. So we're going to grab its ID. We're just going to hard code this for the sake of a demonstration. And we're going to say that it's moving to the northeast, which means it's moving to this dark square here. So we're going to grab that ID as the destination. And we said we're moving to the northeast. So that would be our action. So let's go ahead and save. And then over here, we're going to click on the machine link. And we see that it did happen. It just happened so fast that we barely saw it. So I think what I'm going to do then is I'm going to change the timing function here where we're calling auto move instead of the minimum delay. We're going to delay the full second. So let me just refresh the page here. It should take about 1 second and then it moves. Okay. And ignore the errors down here in the console. That's just because we were hard coding the data, and doing this is not appropriate because when the piece moves, the X and Y position changes. So the ID changes, so we can't just keep returning this static value. So I think we're going to finish up this video by implementing this function. It's going to take some time. It's a rather complicated function, but once we get it done, a huge portion of the game logic will be done. So here, we're going to start this very similarly to some of our other functions, where we have a bucket to store possible moves. We also need to know the X and Y position of the piece that we're getting moves for. Okay, so we're passing an ID into the function, so we do have an ID. So at this point, we have our possible moves bucket and we have X and Y coordinates. The next thing we need to do is we need to define forward east movement. And you might be wondering, well, why are you talking about forward east as opposed to northeast or southeast? Well, because this function can be called for either side. So for a normal non-kinged piece on the red side, a northeast or northwest move is valid, but the same is not true of black, right? So of a black piece that's not kinged, it's only a southeast or a southwest move that is valid. So what we really care about is forward and backward direction, and then we'll have to have a conditional to check for whose turn it is, and then use that information to determine the direction of the move. So we need to look at the new X and Y coordinates. So the new X, in the case of a forward east movement, is going to be X plus 1, because forward only matters to the Y component. It doesn't matter to the X. East means the X is increasing regardless of whether it's red or black. So let's look at the Y component. Now this one's going to be a little more complicated. So the Y component is going to be Y minus, and then it'll be 1 times a new constant that we're going to call direction of play. So let's define direction of play, and then I'll talk about what this is doing. So direction of play, if the current turn is red, then the direction of play will be defined as 1. Otherwise, the direction of play will be defined as -1. And so if you consider a red piece, then your direction of play is 1, and therefore 1 times 1 is 1. And so when red is moving forward, its y is decreasing. So this ends up being y minus 1. Now, if we're talking about a black piece, then direction of play is -1. 1 times -1 is -1. Y minus -1 is the same as y plus 1, which is good, because if you're a black piece talking about moving forward, you do want the y to increase. You do want this to effectively be a plus. And so that's what we're accomplishing here. Next, we're going to store the new destination ID and then the new action. And so this is going to be a board location. So that's b underscore plus new x plus underscore plus new y. And we're going to use that when we're generating the piece that we're going to append to the move that we're going to append to the possible moves. And then for our action, if we're talking about forward east movement, we know the result in this case is either going to be move piece southeast or move piece northeast. And so the way we're going to do that is very similar to how we defined direction of play. So if it's red, then we're going to move the piece to the northeast. And that's a string. Otherwise, forward east movement is going to be moving the piece to the southeast. Okay, so now we need to do a little bit of logic around when it's okay to add this move. So the first thing we need to do is we need to check and see if the board piece even exists at this proposed location where the piece is moving forward and east. So that we'll use this function here, is board square present at location. We're going to tab that over because we're using it. Okay, we're going to give it our new x and y coordinates, and we do want this to be true if we're going to append a move or push a move onto the array. So that's good. And then we also want to enforce some other stuff. And we want to enforce that a piece is not present at that location. So exclamation point in front of it, using the same new x and new y coordinates. So basically, we want to make sure that there's a place to move to, and we want to make sure that it's available to move to. And if that's true, then we're going to push a move onto the array. And the source is going to be ID, which is the parameter that we passed into the function originally. And then we're going to have some destination, which is going to be our new destination ID. And then we're going to have an action, which is our new action. So there we're passing a move, which comprises of a source, a destination, and an action. So all of this is 1 out of 8 scenarios. Let's move on to the second one, which would be forward, westward movement. So we're still moving forward. So the y will behave exactly the same as before, but the x will be inverted. And because we're moving westward, our choices of the action are going to be move piece northwest and move piece southwest rather than east. And I think that is all we need to do for that one, except we're going to clean that up a little bit. Okay. So now we want to do a forward jump to the east. I probably should have chosen west. But okay, we'll change all these. Okay, so when we're doing a forward jump to the east, we still need to get this square that's one diagonal out, and we still need to do these checks. We need to make sure that the board exists. But in this case, we expect a piece to be present there because we're jumping it. So we want that to be true. We want a piece to be present at the location. I'm going to tab that over because we're using it. But we also want an additional condition. We want to enforce that the piece that is at that location is not an ally. We want it to be on the opposite team. So I might end up using this get team from piece function, but I might also just create a new function called get opposing team. And we're going to base that on the current term. So if the current turn is red, then we're going to return black. Otherwise, if the current turn is black, we're going to return red. Okay, let me think for a moment about how I was going to use this. I might have just written a function for nothing. Well, okay, so we want to make sure that two pieces are not allies. And one of those pieces is going to be the one that we're getting moves for, the ID that we passed into the function. And the other one, I think we're just going to build an ID. So that'll be p underscore plus new x underscore new y, and then underscore. And then we're going to use that get opposing team. Which is going to return either red or black. Let me make sure that it's returning the right casing. Yeah, it is. So lowercase is what we want. So basically, we're generating the ID of the piece that we want to make sure is on the opposite team. It's very similar to this new destination ID, except we're basically generating the piece version of it. And so if there is no such piece, then no such ID will exist. And so here in pieces are allies. Oh, okay. I need to enforce that these IDs are real here. Oh, I can just use this get piece from board square, which I forgot that I had. So that probably means that we do not need this get opposing team function. Because we know that ID exists because that was the result of a previous query for pieces. And getting the piece from the board square will also enforce that the piece exists. And then that'll be used to check whether or not the pieces are allies. Okay, and then this will be from the new destination ID. Pieces from board square. Yeah, that looks right to me. So we're using that one now, so we can tab that over. Okay, so what are we doing here? Let's regroup. So this new destination ID, that's the board location that is one diagonal unit away. And we're saying the board must exist at that location, a piece must be present, and the piece must be on the opposing team. So now what we need to do before we add a move is we need another if statement. We need to interrogate the piece that is two diagonal units away to make sure that it exists and that there's no piece there, so that it's actually possible to jump to that location. And we're talking about jumping, so we need to make sure that we use the correct actions. So the first thing we're going to say, we're going to update the X and Y to be 2 units away. Okay. And then we're going to get a new destination. Maybe we'll just move these. Let's see, no, I am using that. But we will, okay, so I'm using this, so I need to keep this here, but we may copy it here because I'm going to be using the new version of it that's 2 units away instead of 1 here. I don't think we need this line. Okay, so now here we're 2 units away. So this is 2 units away. Oh, did I just delete a line without moving it? Put that there. Okay, so now we've got our new action. Okay, so we're going to enforce that the 2 diagonal unit away location exists on the board, and we also must enforce that there is not a piece present there. Not. Okay, and that is it for forward jump east. So we've done the bulk of the heavy lifting because we have one example of this type and we have one example of this type. Let's copy that real quick. So we're going to do forward jump west. So forward is the same as before, so the y isn't going to change. It's just the x that's going to invert there to a minus. And same with this, minus. And we're talking about wests, not east. So we'll update those. And that's all we need to update there. Just double checking. I don't see anything else that needs to change. So I think we're done with 4 out of 8 conditions. So I'm going to copy all 4 blocks here. So the other conditions are if the piece is a king, then it will also be able to move in the reverse direction. So if is piece kinged ID, so now we're calling the is piece kinged function, which is this one. So we'll tab that over. Okay, we're calling this one as well. In fact, I'm going to rename this. Instead of pieces are allies, I'm going to say are pieces allies. And we are using it, so I'm going to tab that over. Okay, that one we're not using yet. And that one we're not using yet. I'm just kind of looking at the functions here. I think for now, we're going to get rid of this function and we'll just incorporate it as part of updating information in general. Okay, so if the piece is kinged, then instead of forward direction, we're talking about reverse. So the east and west is not changing, so the x is not changing. It's the y that's inverting. So we're going to invert that y to a plus and a plus. And we're going to invert norths to souths and souths to north. Okay, now we're going to do the same thing for the jumps. So there's going to be two things to invert here and two things to invert here. And then we need to invert north to south, south to north, and save. And then we need to remember to return the possible moves after we've pushed all the possible moves onto it. And I believe that is it for this function, which we know is being called. So I'm going to save that. And I'm just going to refresh. We'll just see what happens. Okay. So it doesn't like something. Okay, maybe I'm passing it something that it's not expecting. So like when I'm passing get piece from board square. Oh, that's returning the element. Okay. So we'll do dot ID, dot ID, and there's probably going to be 4 of these. Yes. Save it, refresh. Okay, and so we see once per second, it's just doing its auto move, and it'll probably have an error at the end when there's no more valid moves for this team. And of course, we've not implemented alternating turns yet, but I think I'll save that for another video. And there's no more valid moves now. And yeah, it had some sort of error. But you could see that every second, it was doing an auto move. And we'll see very soon, probably in the very next video, when alternating turns are implemented, we'll start to see real gameplay occurring. That'll do it for this video. Thank you for watching.